Hello everyone, here's another IB Physics past paper question. This was from 2018 May, and this is the standard level paper 2, and this is question 4. Pretty simple this time. We've just got ourselves a circuit, so we can see obviously there's a drift speed represented by these dots and these vector arrows. So it's a conductor, an ohmic conductor. So in other words, it's going to behave as an ideal ohmic object, and it's connected again to an ideal ammeter, so no resistance in the ammeter, and there's our power supply. So this would be the direction of the electron flow, and that's represented by this drift speed within this shape, of which we know some dimensions. So we're then given the dimensions below. We're given the width, the height, and the length. So it's 10 centimeters long and 0.02 centimeters in cross-sectional area. Resistivity, represented by the rho, is 1.7 times 10 to the negative 8 ohm meters. And then we're also given the density of free electrons in per centimeter cubed. We're then told the ammeter is giving us a reading of 2 amps, and our job, first of all, in part A, is to calculate the resistance of this particular conductor. So bringing in our data sheet for resistances, hopefully you can recall it's going to be topic 5. Here's all the formulas that we have available, and we are recognizing that we've got rho, the resistivity. We've also got the length and the cross-sectional area. So hopefully you can see pretty easily that this guy here is going to be our formula, and we're really just going to plug and chug and solve for resistance. So let's go ahead and solve. There's our formula. Rho, resistivity, is the resistance times the cross-sectional surface area divided by the length. Rearranged and solving for the resistance, it's going to be resistivity multiplied by the length divided by the area. So let's put the values in. What do we have? Well, we've got resistivity is 1.7 times 10 to the negative 8 ohm meters. We've got the length, which is 10 centimeters. 0.10 meters, divided by the area, which of course is the cross-sectional area, which is going to be let's leave it like this, 0.02, but I'm going to go times 10 to the negative 3 to get my meters. Nope, negative 2, because I'm in centimeters, apologies. Negative 2, and that's in meters. And that's going to be times the same thing because it's a square surface area, times 2 times 10 to the negative 2 meters. And that's going to give me, if I plug all that in, that's going to give me my answer, which is 0.043. And I've gone to 2 significant digits because I've got 2 significant digits in my question information. And the units, well, let's just quickly check that we've got those. It should be in ohms, of course, because we're finding resistance. Let's just check that we have all of the cancellation we need. Well, meters and meters, meters and meters, leaving us with ohms. There we go, pretty straightforward. Okay, part B, we're now just calculating the drift speed. So hopefully you can recall. If not, you can use your data sheet. But here's the drift speed equation. So the current is going to be equal to the number of charges per unit volume, that's this N, multiplied by A, which is the surface area, V is the velocity, the drift speed, and then Q is the charge. So what we're really solving for here is V. So I'm just going to move this over a little bit, leaving our equation there. I need to take my equation, which is current is number of charges per unit volume multiplied by the surface area multiplied by the velocity multiplied by the charge. So I'm going to solve for v, the drift speed. We also need this to be in centimeters per second. So just going to be careful of that when I'm doing my units. So I'm going to rearrange. I'm going to solve this for v. So it's current divided by NAQ. Let's go ahead and put the values that we know into this. Well, the current was given in the question. It's 2, so 2 amps divided by N, which is the charge per unit volume. Again, a value given to us in the question. It's 8.5 times 10 to the 22. And let's write this out. This is going to be electrons per centimeter cubed. Okay, there we go. Let's keep going. Multiplied by, this keeps going across. Let's do another parentheses. Multiplied by the surface area. Well, the surface area is going to be 0.02 centimeters, because that's given to us in the question, times 0.02 centimeters given in the question. And then the charge, let's keep this going all the way across. The charge, of course, per unit would be the elementary charge, because we're dealing with electrons. So 1.6 times 10 to the negative 19 coulombs. Okay, we're going to be keeping track of our units, so let's get rid of amps and turn that into coulombs per second, because that's really what it is. And now we can start looking at our units before we plug the numbers in. So we've got centimeters cubed is going to be gone, and it's just left with centimeters. And then we've got coulomb, cancelling with coulomb. Centimeter is going to come up to the top. So we get centimeters per second, and that is looking pretty good. If we plug in all our numbers into our calculator, we're going to get a value of 0.3 64 centimeters per second. We need to solve this for two significant digits, so 0.7 and centimeters per second, or we should use proper IB annotation here, centimeter second, which is what it was asking to begin with. And there we go, that's the velocity, or the average velocity of those electrons in the conductor as they're drifting through.